over section 4.2, and it's on systems of linear equations. And today specifically we're gonna do substitution, so solving systems of linear equations by substitution. This is just a review. I was gonna show you how systems, what a solution means. So for example, that's a line, that's another line, so that's a system. There's two lines, and this type has one solution. So one point of intersection, which is the red dot, it's one solution. This one, that's how the graph looks, where they intersect at one point. So this system has one solution. This is the other system where there are parallel lines, and this one doesn't have any solution, because solution means where they intersect. These lines never intersect, so they don't have a solution. That's how it looks, parallel lines. Then the last one would be when it's the same line, so the black one is one line and the red line is the other line, but in reality it's the same line. So same line would mean infinite number of solutions, and that's how the graph looks, which is one line. And this is a review from Algebra 1 and Algebra 2. Okay, so I'm not gonna cover like they would in Algebra 1 or 2. This class goes faster than that. So let me solve for this one. So, and I'm gonna do it in steps. So I would say label the equation just to make it easy. So you don't have to, but this would be equation 1. I'm gonna do it for the notes. That would be equation 2. Equation 1 and equation 2. So step 1 would be, in this case, if you notice, that one's already solved for x. So for this type, when you already have that, all you have to do is substitute equation 2. Substitute equation 2 into equation 1. So we're substituting this into that. So I'm gonna rewrite it. I'm gonna rewrite equation 1 because that's where we're substituting. And x, so I'm gonna leave 2, which is that 2, and then I'm parentheses plus y equals 10. So inside I'm gonna put equation 2, which is already solved, which is y plus 2, because x is equal to that part. So I'm only putting that part, the second part, for that x. And then after that, all I need to do is solve. So you distribute here, so you get 2y plus 4 plus y equals 10. So combine these two terms, so that would be 3y plus 4, so I'm combining these two. There's a 1 here. Equals 10, and then solve for y, so minus 4, that becomes 0, so 3y equals 6. And then carry over here is not going to fit. So we have 3y equals 6, so divide by 3, that becomes 1, so y equals 2. So we found y. So step 2, since we already have y, in the first step 2 for this equation would be for me to find x. So step 2 is to find x. So to find x, we need to substitute that 2 into any of these two equations. So I'm gonna substitute into that just because it's easier. So which one am I? I'm gonna use equation 2. You could have used equation 1 also. So what am I doing? X equals parentheses plus 2, and what goes in equation 2? The y. Instead of that y, we're gonna use 2. We're substituting. Maybe I should put it here, since y equals 2. I'm gonna put it for the y for that equation. Equation 2. So x would be 4. So the solution goes x and y first. So x first, which is 4, and then y, which is 2. So that would be the solution. So this would be an equation like this, where they intersect at one point, and that point is the intersection, and you denote it like that. It needs to be in this order pair form. Okay, equation 2, legal example 2. So I'm gonna name that equation 1 and equation 2. Equation 2 it's already solved for. So this is the one where you can, so for step 1 for this tab, you can sub equation 2, which is solved for, into equation 1. So I'm gonna write equation 1 minus, and then that one parentheses equals -2. So I'm gonna put the 3x, which is this one, equation 2 into equation 1. So that's equation 2, and this thing inside is equation 1. So what happens? That would be just 5x minus 3x equals -2. That would be 2x. These two terms, you combine them, and then you have -2 on this side. So divide by 2. So x equals -1. So we found x. So for step 2, since we already have x, we are going to find y in this case. So what's x? So x equals to -1, and we're going to substitute into any of these two. I'm going to substitute it into equation 2 to make it easy, which is that one. So you're going to have y equals 3 times the x. So I'm going to put parentheses. And what's the x? The x is -1. We found it. So y is -3. So the solution for this system would be, remember, it's x and y. So x goes first, which is -1, and then -3. So that's the solution. Now example 3. So for example 3, let's name it equation 1, equation 2. So for example 3, the equations are not solved, so you're going to have to solve for 1. So the steps here get a little bit longer. So step 1 would be solve for 1 equation. Solve for 1 equation. And when I mean solve, is for x, or I'm going to put x or y. You decide if you want to solve for x or y. It doesn't matter. Sometimes it's easier if you solve for 1. But in this case, I'm going to solve for the first one. So using equation 1, I'm going to solve for x, since it's already by itself. So solve for x. So solve for 1 equation, x, for x or y. So I'm solving for x. For x. So x equals -2y plus 7. So that's the first step for this type. Step 2 would be to substitute. Sub this equation 1, because we solve for equation 1. Sub equation 1 into equation 2, into the other equation. So copy that. So 2 parentheses plus 2y equals 13. So what goes inside the equation that we solve for? So instead of having that x, we're going to have that -2y plus 7. now distribute, so negative 4y plus 14 plus 2y equals 13. So here we're going to combine the like terms, which is negative 2y plus 14 equals 13. So negative 14, that's 0, so negative 2y equals negative 1, so negative 2 becomes 1, so y equals 1 half. So we found y, which is 1 half. So step 2 would be, step 3, to find what we're missing x. So we're going to find x. And you can substitute into any of these two, even that, because that would be that equation. But I'm going to use the one on top not to confuse you. So I'm going to use equation 1. And we know y equals 1 half. So what is equation 1? So we have x plus 2 times 7. So remember, instead of that y, we're going to use this number, because that's what y equals to. So 1 half. So x plus 2 over 2 equals 7. So x plus 1 equals 7. Then minus 1. So x equals 6. So we found x and y. So the solution, I'm going to put it here. Remember, it's x and y. So x is 6 and y is 1 half. 6 and 1 half. That's the solution. For example 4, let's go quick. Example 4, again, they don't solve for any of them, so you're going to have to solve for one. So I'm just going to label this equation 1 and equation 2. So step 1, so for x or y, for one equation. So you guys will pick which one I'm going to solve for. Now it's easier because y it's already solved. Y it's already by itself, so I would solve for this one. So I'm solving for equation 2. So negative 3x plus y equals 6. So all you have to do is add 3x to both sides. So y equals 3x plus 6. So we already solved for 1. So step 2 would be to sub, that's equation 2, right? Which is this one. Equation 2 into equation 1. So copy equation 1. 7x minus 3, and then instead of the y, we're going to substitute for y. So put the parentheses equals negative 14. And for this space, for y, you're going to put this part. 6. So then distribute 7x minus 9x. 3 times 6 minus 18 equals negative 14. Combine like terms, so that will give you negative 2x minus 18 equals negative 14, so plus 18. That's 0, so negative 2x equals positive 4. Divide by negative 2, so that becomes 1. So x equals negative 2. So the last step, well, not the last, yeah, the last step would be find, since we have x, we're going to find y, we're missing y for this one. And you can choose either or. I'm going to choose the second one again. So I'm going to use equation 2. Let me write it here again so that you know what's going on. So negative 3, you're going to put parentheses because we're substituting for x, plus y equals 6, and we're going to substitute negative 2 here. So 3 times 2 would be positive 6, both are negative. And bring the 6 to that side, so y equals 0. So the solution, remember it's x and y, x is -2, y is 0. That would be the answer. So the first 4 examples are of this type, remember, where you have 2 different equations and the solution is in a section. The next 2 examples is the special cases where sometimes you're going to get a parallel line or the same line, parallel lines or the same line. And those do happen also in systems like we did with equations. That's how they look. They look almost the same. You're going to get a false and a true statement for both. So for example, 5, so for example 5, so we're going to do the steps. This is already solved for. So when something's solved for, all you have to do, so that's equation 1 and equation 2. So we're going to substitute sub equation 2 into equation 1. Right, equation 2 into equation 1. So copy equation 1. Let me copy her. This is equation 1. 1 half x minus y equals 3. We're going to sub that. So 1 half, and then we're going to put parentheses for x, because we're substituting for x, minus y equals 3. So x would be 6 plus 2y. And then you distribute. 1 times 6 would just be 6 over 2 plus 2 times 1 would be 2 over 2y. Then you have that minus y on the outside and then the 3 on the other side of the equation. So that would be 3 plus, that would just be 1. So y minus y equals 3. So what happens here? Y minus y, they become 0, is 2. So you get 3 equals 3. So again, when you get a true statement, so this would be a true statement because 3 equals 3. They're the same number, so that's a true statement. So what does that mean? It means the 2 equations, so these 2 equations are equivalent, or they're the same, they're equal. So when that happens, the solution would be infinite number of solutions. So infinite number of solutions when that happens. Okay, the last example is the other case. Okay, before we do that, I forgot the graph of this would look like, so that's y, that's x. So you're getting a line like this for one of these, and then the other one is on top of it. So it's the same line. That's why everything in the lines, it's part of the solution, because whatever number you pick, it's gonna solve for these 2 equations because they're the same equation. Okay, for this one, so let's do step 1. Step 1, since we haven't, none of them are solved, you're gonna pick one and solve it. I'm gonna solve for this one. So this is where you solve for x or y. Solve for one equation. I'm gonna pick equation. So this is equation 1. That's equation 2. I'm gonna solve for equation 2. So equation 2. So it's this. And yeah, like I said, you can solve for x and y. I'm gonna solve for x because it's easier. I'm gonna avoid fractions and stuff. So 8y. So again, you can choose to solve for x and bring it over and then divide by 8. but I'm going to do the other way. So negative 4x, so that becomes 0. 8y. So you divide by 4, and you could solve it the other way, but I don't want fractions. So that would be negative 2y. So I solve for this equation 2 for x, and that's what I get. So for step 2, that's when we sub equation 2 into equation 1, which is this one. So let's copy equation 1 first. 6x plus 12y equals 5. So we're substituting for x, so you're going to put 6 times parentheses plus 12y equals 5, and then what goes inside this negative 2y. So distribute 6 times 2, negative 12y plus 12y equals 5. So these two become 0, so you get 0 equals 5. So again, when you get a false, this is a false statement. So this means it means the lines are parallel. So when you get this, there's no solution. So no solution. And graphically, so imagine this is the y and the x. So these lines go like this, and they never touch each other. Since they never touch each other, they don't have a solution. To have a solution, meaning it means that you have to intersect. So this one never intersects because they're parallel, so they don't have solutions. That one intersect everywhere because it's the same line. And then the other types, they intersect once, so they're going to have one solution. And there's cases later on, I don't know if we're going to cover it, I don't think for this class. The graph might look differently, you might have touched each other more than once, but not in these sections. That's it. Thank you, guys.